Hello for everyone. In today's lesson, or just in today's presentation, we just continue random variables. This is a lecture we studying continuous random variables. Continuous random variables can take any values without a given interval. Unlike discrete variables, continuous variables are measured, not counted. They can take infinitely many possible values depending on measurement accuracy. Examples of continuous random variables include time, distance, height, and temperature. Continuous probability distribution describes how probabilities are spread over an interval. They are defined using probability density functions for continuous distribution. Probability represents by the area under the curve. The total area under the curve is always equal to 1. For example, we calculate probabilities for waiting times using intervals, not exact values. The uniform distribution is a continuous distribution where all values are equally likely. This means probability density is constant over the interval. The distribution is defined between a minimal value and a maximum value b. Outside the interval, the probability is 0. For example, a random number generates between two fixed limits follows a uniform distribution. The uniform distribution has simple mathematical properties. The mean of a uniform distribution is equal to average of A and B. The variance depends on the width of the interval. The graph of the distribution is flat, with no peaks or skewness. For example, a uniform distribution between 2 and 6 has the same probability at every point. The normal distribution is one of the most important distributions in statistics. It has a bell-shaped and symmetrical curve. In normal distributions, the mean, median, and mode are equal. The distribution is equally described by its means and standard deviation. For example, humans' height often follows a normal distribution. The means determines the center of the normal distribution. The standard deviation controls how spread out the data are. Changing the main shifts curve left or right. Changing the standard deviation makes the curve wider or narrower. For example, exam score often follows normal distribution with different spread. Standard normal distribution is a special normal distribution. It has a mean of 0 and standard deviation of 1. Any normal distribution can be coded into the standard normal distribution. This conservation is done using the z-score. For example, z-score allows us to compare values from different normal distributions. Finding normal probabilities distribution. We first covered x value to z value. Z-score shows how many standard deviations a value is from the mean. After finding the z value, we use the standard normal table. The table gives cumulative probabilities. For example, we can find the probability that x is less than a given value. The exponential distribution is used to model waiting time between events. It only appeals to positive values. The distribution is defined by single parameters. It has a memoryless property, meaning past waiting time does not affect future waiting time. For example, it can model the time between customers' arrivals. Continuous probability distributions are widely used in real life. They are important in operations management and quanting systems. Normal distributions are used in finance, economics, and quality control. Exponential distributions are used to analyze service and waiting times. For example, businesses use distribution to improve service efficiency. Thank you for your attention.